Hey everyone, welcome back to the channel. In today's video, I will walk you through how to run a batch inference job on Amazon Bedrock using any Bedrock available model. For example, we are going to use LLaMA 3 series model with all input and output which is handled by S3 bucket, which is a requirement to run inference job in AWS Bedrock. So inference job we are running as a batch. We will do using Google Colab, Boto3 and the Bedrock APIs. Let's get started. So first we install the required library, which in this case is Boto3. The version is latest one 1.37.18. Make sure you have upgraded your Boto3 library. We imported all the required libraries here. The most important is Boto3 here. Then two things are required. First is the object for the Bedrock connection. So we use the Boto3 and then we call the client of Bedrock. So it can be Bedrock hyphen runtime or a alone Bedrock itself. So make sure for batch inference job you have to be put only Bedrock, not Bedrock hyphen runtime, which is for the single request required. It is required AWS access key, AWS secret access key, which you will get from your console, Bedrock console. Same for S3, because in the batch whatever number of prompts we are going to pass, it is going to be stored into the S3 bucket, the input data. And finally what LLM is going to predict, that is also going to dump on the S3 bucket again. So you can define the folders inside the S3 bucket after choosing your bucket which you want to choose as a main bucket. So there would be different keys for that as well, as you know. So you find those keys from the S3 console, but make sure all the permissions are accessed to the Bedrock AWS Bedrock. So for the S3 connections, so everything needs to be given as a permission. Then here there is again important thing called job role ARN. So role ARN is just this kind of format we will having for the batch inference job running on AWS Bedrock. So you will be getting some 12-digit number. It will be unique for you. I'm using the user data for now because I don't want to showcase all those credentials. That's why here you can see I imported from the google.colab import user data. That is fine. Then we have to choose the model ID for which you want to run do your inference job. Now the most important steps comes where you prepare your model inputs. So I made a connection with S3 buckets to get some content, file content, which I am passing as in the prompt. Either you will be having all the things in the loop, those variable component in your prompt, which in this case is a right and accurate 250 word gender neutrality. This is the fixed one kind of system prompt, but this file content is just a dynamic thing, and it will vary for each and every prompt, right? Something unique will be there to ask any LLM. This prompt will be going into the body, and the body is just a JSON object where we have the prompt key, all those LLM keys which is required in your case. So temperature can be anything between 0 to 1. Max generation length is 300 tokens. It depends on your LLM capability as well. So in my case I chose LLaMA 370 billion. So I'm guessing it considers 128k context words. It has a lot of capability to store the multiple context words. Now this body will be going to the model input dictionary. So model input is having two keys, record ID and model input. Record ID is just a unique key because I imported datetime now, which is the use of this, and the UID, which is a unique record ID for each and every prompt. Okay, so this is one of the copy I made, and then I just replicated for 100 times this prompt. I just do the copy of every prompt what I generated here, and then I am inserting again in the model inputs list, which is just a list of prompts, list of having prompts. So make sure you should have at least 100 records, 100 prompts at least, because minimum it supports 100 prompts in a batch. But if you have running only 100 prompts, it is not going to give good throughput. It will take more time. So make sure you should have good enough length of prompts, enough number of prompts available in a batch, like 1000, 5000, or 10,000 prompts instead of 100 prompts, what I'm showing here right now for the demo purpose. But because it now you can scale it. If you are using number of prompts higher, then the throughput will be not that much, and you are going to get good uh, results with good throughput as well. So I just checked it for 100 prompts. It was taking around 8 minutes, which is not good at all, right? But once I make it 1000 prompts in a batch, it took only 10 minutes, which is good because now it is not taking that much of time by increasing the number of prompts. So you will run this method called we will run this method called prepare model inputs. After that, I am going to write a method called I have written the method for upload to S3 bucket, because the input data you are going to create needs to be uploaded somewhere. So this is the method which helps us to upload S3 upload our input file, which is 100 prompts in a batch. Then I'll create a method called write JSONL, which is just to write whatever list we having, this model inputs list will be having, we are going to write in a file. So first I call this method called prepare model inputs, which will create my model input JSONL. I just printed here. So each object is having those unique record IDs, model input, which is having prompt, all those LLM configurations we have. This is 100 times because we have created 100 prompts in a batch. Now we create a file name and we are going to write into some S3 bucket. So upload it to S3 will call with the file name and the bucket name, and inside bucket name you will be having some folders, subfolders where you are going to store it. So I made this name and I uploaded into the batch jobs inside that. That is fine. Then we'll create the S3 URI, S3 URI for output data and S3 URI for input data. So this is the thing you have to write it for because this will give us the location, the input data location, the output data location. Finally, we'll use that object, Bedrock object we initially created, where the runtime was it was only Bedrock because we are doing batch inference job, and we are calling this method called create model invocation job, which will initialize our batch job. So we'll pass the role ARN, model ID, the LLM model, the job name. Then we have the input data config and this output data config. Finally, we'll check whether once we submit it, we have to check whether it's in the completed or failed state. So if it is completed, then our S3 bucket object batch output bucket will be having the LLM responses for each 100 prompts. So in this object we will be calling this method called get model invocation job for that particular job ARN, which we will getting from the AWS Bedrock console. And this is will running in the status. If it is not in completed or failed, any status between this will keep checking this thing, the job response, and if it is completed, then well and good enough. If it is failed, then we'll see the reason why it is failing. We'll solve it and we'll run it again. So it's submitted first. That is the first stage. Then the validating is the second stage. Third stage is we will having a scheduled state. Then in progress state, which is the last state before completed. After that, we have finally the completed state at the end. And once it is there, then it will break from the while loop. And the total time you see for 100 prompts, it took 477 seconds, which is around 7-8 minutes, which is very high, right? So to reduce it, we need to increase the number of prompts, either 100,000 or 5,000, 10,000, anything you can put. Then finally, once it is completed, it means it is saved into the S3 bucket. The location we decided was batch output jobs, and this is the batch ID for us. So this is the location you will see in the console to verify it, and it is the where it is will be saving this LLM responses. So we'll read that file, and the file, there would be two files over there. The manifest is the second one, which you don't need. First one is the output.json L file. It is in the JSON list format, so each JSON object will be there in file sequential way, and then once we read it, we load into the JSON object, and we will having the model output. From that we'll pick the generation one, which is the actual LLM response. And finally this answer will be there, and you can check the length of that answer is 100. So 100 prompts are there, right? That's it. Thank you for watching this video, and please subscribe and like this video. Thank you.